Honor 200 Pro Camera Test. Hello my dear friends, how are you? I hope you are well and in good health. Today I have a new and important video with you, which is testing the Honor 200 Pro camera. I hope you like it, but before you watch the video, subscribe to the channel to receive everything new and useful. Now let's continue the explanation. We put the Honor 200 Pro through a battery of rigorous XMark camera tests to measure its performance in photo and video quality and zoom from an end-user perspective. This article explains the device's performance in a variety of tests and several common use cases and aims to highlight the most important results of our testing with a snippet of the data captured. Overview. Main camera specifications. Primary camera, 50MP, f/1.9 lens, optical image stabilizer, 27mm effective focal length ultra-wide camera, 12MP, f/2.2 lens, 16mm effective focal length remote camera, 50MP, f/2.4 lens, optical image stabilizer. Positives: fast and accurate autofocus in all tested conditions, generally accurate subject exposure in most tested conditions, with a fairly wide image dynamic range, fairly neutral white balance in outdoor photography, good balance between texture and noise in outdoor conditions, details are well preserved in long range shots, negatives: slightly low contrast in high dynamic scenes and the image, occasional color vignetting in photos, and slight oversaturation in video, especially in reds, oranges, and skin tones. Texture and noise impact are generally low in indoor and low light conditions, with some color noise, occasional effects such as glare, halos, and color modeling. The Honor 200 Pro is a versatile and capable smartphone, with a triple camera setup that brings with it plenty of photography options. Honor calls the 50MP f/1.9 main camera on the 200 Pro a studio-level portrait camera. Marketed as a master of portraiture, the device has the makings of good portraiture, thanks to reliable autofocus, accurate subject exposure, and a fairly wide dynamic range, although some color instability was noted. As for colors, occasional tints and skin tone inaccuracies were occasionally visible. The images also contained some color noise, especially in low light conditions. Strong backlight conditions can also result in decreased contrast in images. The Honor 200 Pro's strong performance in autofocus, exposure, and well-controlled noise in video were offset by stabilization inconsistencies, which were evident when shooting walking action videos. Test summary about XMark camera tests. XMark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, in which a sophisticated set of metrics allows a group of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the XMark camera protocol, click here. More details about the smartphone's camera scores are available here. The following section brings together the main elements of XMark's comprehensive tests and analyzes. Full performance evaluations are available upon request. Please contact us to find out how to receive a full report. Image. The Honor 200 Pro's autofocus was very good thanks to the effective integration of zero shutter lag technology. This kept the subject in focus even in low light conditions. Facial detail was fairly high with a good noise level, especially when taking photos outdoors. The extended dynamic range maintained a good level of detail on faces as well as backgrounds even in difficult lighting conditions such as backlit shots. However, colors were not always accurate in outdoor conditions, especially sky, and sometimes in low light. Difficult backlit scenes will result in images with slightly low contrast and lens flare. Color noise can be visible, especially in low light, along with some local loss of detail. The color exposure and color are key features of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors that are evaluated are contrast and dynamic range. For example, ability to provide visible detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Autofocus f-tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field can be pleasing for a portrait of a single subject or a close-up, it can also be problematic in some specific circumstances such as group portraits. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured, from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of subjects and images captured in the lab as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on histogram images captured in different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are the Xemark, DMC, proprietary chart and the dead leaves chart. The noise tests analyze different noise attributes such as density, color, granularity, and structure on real-life images as well as histogram images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also on dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are performed on histogram images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The chart used is the dead leaves chart and the standardized measurement is visual noise derived from ISO 15739. Archaeology. The effects assessment addresses lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantization, and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and frequent the effects, the greater the points deducted from the score. Below is a list of the main effects observed and corresponding point loss. Bokeh is tested in one custom mode, typically portrait mode or aperture mode, and is analyzed by visual inspection of all images captured in the laboratory and in natural conditions. The goal is to reproduce portrait photographs similar to those taken with a DSLR and a wide aperture. The main image quality attributes that are paid attention to are depth estimation, artifacts, blur gradation, and the shape of blur lights and bokeh. Portrait image quality attributes, exposure, color and texture, are also taken into account. For portraits, we tested the device in aperture mode with the vibrant color option, which is the default setting. In our testing, the Honor 200 Pro efficiently isolated the subject and showed accurate depth estimation. Preview tests analyze image quality in the camera app's preview of an image, paying particular attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color, and focus adjustment are also evaluated when zooming from the lowest zoom factor to the maximum zoom factor available. Preview frame rate is measured using the global LED timer. Zoom in. The Honor 200 Pro zoom capabilities were very good. The ultra-wide lens has a minimum focal length of 15.8 mm, providing a 112-degree field of view, which is slightly lower than some of its competitors. Images have a good level of detail, despite the slightly limited field of view. With 2.5x optical zoom, the level of image detail remained very high, up to 70 mm. Beyond that, telephoto image quality declined somewhat under digital zoom, although the level of detail was acceptable even at long range. In the video mode tested, 4K at 60 fps, the ultra-wide camera is not available, which impacts the zoom video user experience. However, in telephoto mode for telephoto video, Details were generally preserved well. Wide. These tests analyze the ultra-wide camera's performance at several focal lengths from 12mm to 20mm. All image quality attributes are evaluated, with special attention paid to such artifacts as chromatic aberrations, lens smoothness, and distortion. The images below are an excerpt of the scenes tested. Video. In the video, we tested the Honor 200 Pro in 4K at 60 fps. Video exposure was good, but color was sometimes inaccurate in indoor or low light conditions. Autofocus was accurate and smooth. While noise was generally well controlled, the level of detail was a bit low, despite being 4K. The Honor 200 Pro's camera lacked video stabilization when compared to its competitors, with frame shifts and motion lingering. The color exposure tests evaluate the brightness of the main subject and dynamic range, that is the ability to display visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Color image quality analysis addresses color rendition, skin tone rendition, white balance, color shading, white balance stability and its adaptation to changing light. Texture tests analyze the level of detail and texture in real-world videos as well as histogram videos recorded in the lab. Natural video recordings are evaluated visually, with special attention paid to the level of detail in bright areas as well as in the dark. Objective measurements are made of graphemes taken at different conditions from 1 to 1000 lux. The charts used are Xemark, DMC, chart and dead leaves chart. The noise tests analyze different noise attributes such as intensity, color, granularity, structure, and temporal aspects in real-life video recordings, as well as videos of histograms captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on video clips of histograms recorded at various conditions from 1 to 1000 lux. The chart used is the Xemark Visual Noise Chart. Installation. The stabilization rating tests the device's ability to stabilize shots thanks to software or hardware technologies such as OIS, eyes, or other means. The evaluation looks at residual motion, smoothness, gel artifacts, and residual motion blur in walking and running use cases in different lighting conditions. The video below is an excerpt of one of the scenes tested. Archaeology effects are evaluated using MTF and resonance measurements on an in vitro SFR chart as well as frame rate measurements using a global LED timer. Natural videos are evaluated visually by paying particular attention to artifacts such as aliasing, quantization, occlusion, and color shift, among others. At the end of the video, I hope you liked it, and see you in a new video.